Hello students, and we're now on lesson 8 of the unit 2 and practice problems. Again, make sure you can try to do these yourself first and then come back and check your answers with the video. We're going to start with this little problem right here. It basically starts out, it gives you a description of what's going on, and then it gives you the equation. So there wasn't a lot of thought with this one on how they got the equation. It's you have $5.2 per pound for almonds and $2.75 dollars per pound of raisins, A being the pounds of almonds, R being the pounds of raisins, and altogether she spent $11.70. So we got to figure out what possible solutions we have here. So we have this equation right here, and if you look at this problem, they're always giving you the pounds of almonds, pounds of almonds, pounds of almonds, and then A pounds of almonds. Okay, it's in other words solving for A. So what I'm going to do on that one is, in each case, they want you to solve for the pounds of raisins. So rather than going through and doing the same thing again, we're just going to go ahead and take this equation. We're just going to solve for the R, and then we'll just do a substitute and a solve. So if you look at this equation here, if I want to solve for that, okay, these two are tied together with multiplication, and it's separated from this other term with addition. So since addition and subtraction are lower down on the PEMDAS scale, the hierarchy of operations, we're going to go and move that first. All right. So since this is 5.2a, I'm going to subtract 5.2a from both sides. Okay, and then they go way over on this side, and they just end up on the other side. And then I need to go and just solve for r. So since 2.75 times r is what's going on, I have to undo that with division, and I'm going to divide by 2.75. R being the unknown, 2.75 being the coefficient of the unknown. And I have to divide both sides by that same thing. All right. So what do we get out of this? We find out that R equals 11.7 minus 5.2a divided by 2.75. Right. Now let's just go through here and we'll just figure this out. 2 pounds. So if I take this equation and I put in 2 pounds, okay, so R will equal 11.7 minus 5.2 times 2 divided by 2.75. So you're going to do your math up here first and divide by 2.75, and what you'll receive out of that, you got a 1.3 divided by 2.75. 1.3, 2.75, which of course equals 0.47 pounds. That's 0.47 pounds raisins. Right. The next one goes into 1.06 pounds of almonds. So we're going to take that same equation, put in the substitute in the 1.06 pounds. R equals 11.7 minus 5.2 times the 1.06, all divided by 2.75. And when you do the math there, you end up with 6.188 divided by 2.75. 6.88 divided by 2.75, which of course equals 2.25. 2.25 pounds of raisins. Alright, what we got? Let's see if I can move this out just a little bit. There we go. So there's our math. That's where we're at so far. And our next one is 0.64 pounds of almonds. 0.64 pounds. R equals 11.7 minus 5.2 times 0.64 divided by 2.75. And on that one, you end up with a total of 8.372, which equals just over 3 pounds of raisins, 3.04 pounds. And then this last one is just, they just say A. Well, We pretty much figured that out right up here. This is the A version of this. We solved this thing right. So I like to do it that way first. Me personally, I've always found more success if I'm looking for something. I want to just take the raw equation and just simply go through and solve it for what I'm looking for, and then start substituting in. Rather than substituting numbers in to your base equation that they give you and then try to work this thing backwards, is really clunky. It's much better if you just simply solve for the thing that you're looking for and then start doing your substitute. And you can substitute over and over and over again, and it just flows out a lot easier. So take that little advice. All right. Number 2, here is a linear equation with two variables. That's the x and the y. All right. Solve the equation first for x and then for y. All right, so let's go through that. Very similar construct on each one of those. So you got 2x plus 4y minus 31 equals 1, 2, 3. Okay. So let's go through this. How are we going to solve this? Well, first we have to solve for x, and then we're going to solve for y. So I'm going to make my life a lot easier and get all the variables on one side and then all the numbers over here on this other right side. So that means I got to move that minus 31. How do you move it? Well, you do the exact opposite of what it's doing. So it's subtract 31. I add 31 to both sides. Cancels over here. So the only thing I have left is 2x plus 4y. And that equals 154. Right, now let's solve for x, which means I want to get x all by itself. Right? If I want to get x all by itself, let's rewrite this base equation. If I want to get x all by itself, that means I got to move the 4y over here. So I'm going to subtract 4y. And what do we got? Well, I got 2x equals 154 minus 4y. Solving for x, there's two x's here, and there's a multiplication happening between them, so I'm going to divide both sides by 2. And there it is. There's your equation right there. I've now solved it for x. Let's take these same kind of steps, and now we'll solve it for y. So I'm going to start with the same base equation, 2x plus 4y equals 154. Solving for y, so I got to move the 2x over to here. How do we do that? Subtract 2x from each side. Cancel, cancel. And I get 4y equals 154 minus 2x. Again, I'm looking for just a single y, but I got 4 of them. So I have multiplication happening between there. So I have to divide by 4. Cancels out. And what do I get? Well, y equals 154 minus 2x divided by 4. So there's your two equations that you have for solving for x and y. All right. Now, the question comes up, can I reduce these? Sure. I can go and take a 2 out of both of these if I wanted to, because 154 is even. 4 is even, so that means I can divide this by 2. Whenever I have a fraction and I have an addition subtraction in the numerator, I can separate that. That's the same as 154 divided by 2 minus 4y divided by 2. So what does x equal? Well, 154 divided by 2 is 77. And 4 divided by 2, is just simply a 2. So that is another perfectly good example of what that thing should look like. When you look at 4, over here, you could take out a 2 out of all these. All right, we can rewrite this as y equals 154 divided by 4 minus 2 divided by 4. How many times does 4 go into, well, can we take a 2 out of both of those? Yeah, we can take a 2 out. It's 2 times 77 divided by 4 minus 2 times x divided by, rather than 4, let's just 2 times 2 is the same thing as 4. This is the same as 2 times 2. What can I do? Well, I can cancel a 2 out of here, and I can cancel a 2 out of here. Now what do I have? Well, I got 77 divided by 2 minus x divided by 2. I can rewrite that if I wanted to. Since I have the same denominator, I can put them over the same denominator. I can't go any further, any lower than that. I could leave it here I could have left it here. I could have left it here. It's really whatever the situation may call for. So, equivalent statements, equivalent fractions, if you take out the common factors. Number 3. A chef bought $17.01 worth of ribs and chicken. Ribs cost $1.89 a pound. Chicken cost 90 cents a pound. The equation given right here represents the relationship in the situation. Show that each of the following equations is equivalent to that equation. All right. So we're going to go and look at this equation, and you'll notice what we got here. This thing is solved for a C. So it's solved for C here, and it's solved for R here. So I think that's what they want us to do here. So they want to take this thing, and we want to solve it for C, and then go around for round B for the second one, and solve for the R. So let's just try that. Let's take our root equation that we got. 0.9C plus 1.89 R equals 17.01. And I want to solve for C first. So I got to get C all by itself. How do I do that? Well, let's subtract 1.89R from both sides. Cancel, cancel. 0.9C equals 1701 minus 1.89R. All right? And I want to have a single C, not just 0.9. So I divide everything, both sides of these equations, by 0.9. Cancels over here, so I just get a C. Well, if you take 1701 and you divide it by 0.9, we'll cross here, you get 18.9. So that becomes 18.9. And then you take 1.89 and divide by 0.9. Well, that's just simply a 2.1 R, which just happens to be what they've got right here. So yeah, we just solved this thing, and we got the exact same equation that we were supposed to have gotten. Sorry about my writing, it's not the best. There you go. All right. Now we can take that same equation, we can solve for R. So let's start this next one right here. Let's start with our same base equation. 0.9C plus 1.89 R equals 17.01. Now I'm going to solve for the R rather than the C. So I'm going to go and get everything extraneous over to the other side. So what am I going to do? I'm going to go and subtract 0.9C from each side. Cancel, cancel. And then since I'm solving for R, I have to divide by 1.89. These all cancel. So I just got a simple R here. So now we have 17.01 divided by 1.89. I can split it because I have a subtract in the numerator. And I can rewrite it like this. Right? And when I do that, I can go and take this, and I can go and take out some common factors. You can do the math there. That's the same as this right here. That's the same as a negative 10 divided by 21C. And then this one right here turns out to be 9. Take that number times 9, you get 1701. Right? Now is that the same as this? Well, yeah. Because this is a plus 9 subtract, that's the same thing as a 10 divided by 21C plus 9. So yeah, we get the same exact. We get the same thing as before. Let's go back this out a little bit. There we go. It's a little better. So I took my base equation. Since I have a numerator that has a subtract sign, I can split that into two fractions. And when I do the math, I get this right here. But it's not exactly what they have in the book, so I use the commutative property of addition, and I simply move them because of that. Okay? And that's the start of, that's number 3. Number 4 says a car travels 180 miles at a constant rate. So we're just going to use the good old-fashioned dirt equation. Distance equals rate times time. So the distance is 180 miles. And the rate we don't know, the time we don't know yet, but we're going to go and get a little bit more information on here. So they're going to give us some travel times. We got to figure out the rate. So the best thing to do, when we want to find rate, and you're given an equation, again, like I've always said before, if you're given an equation, like in this case dirt, and you want to go and solve for one particular aspect that's not isolated, do the algebra to solve for the unknown and then start your substitutions, right? So we want to find the rate in this particular instance. So if I want to find rate, that means I got to divide by its coefficient, which is t. T's cancel over here, so the rate equals distance divided by time. And now we can just put those values in here, right? We're going to go through, in this particular instance, we know it's 180 miles. And we just got to divide by the time. Now the time is in hours, so we're going to be getting units in miles per hour, which is fine, because that's what they want over here. So the first one is 180 divided by 5, which turns out to be 36. The next one's 180 divided by 4.5, and that equals 40. Next one, you take 180 divided by 3, and that equals your 60. And then you got 180 divided by 2.25, which turns out to be 80 miles an hour. So as you can see, the faster you go, the less time it takes for you to travel, which I think we all understand that concept. Number 5, continuing on with these 2-item grocery selections. What are we doing here? Bananas cost 0.5 each, and apples cost $1 each. All right, so this is not per pound. Now this is per each. Okay, think of it that way. Select all the combination of bananas and apples that Elena could buy for exactly $3.50. So you can see your equation right here. The price per banana times the number of bananas plus the price per apple times the number of apples, giving you precisely $3.50. Right? So 2 bananas and 2 apples. Well, that 2 times that is, if you try the first one, that's 0.5 times 1. There's going to be times 2 plus 1 times 2. Well, that's going to be $1 plus $2, which is 3. So no, that don't work. Next one, you have 3 bananas, so 0.5 times 3 plus 1 times 2. Well, 3 times half, that's 1.5. And 1 times 2 is 2. Well, 2 times 1.5 is in fact 3.5. So that one does work. So B is the correct answer. C, you got 1 and 2. So you got 1 and 2. When you do this, you get 2 apples and 0.5 on the bananas, so that ends up 250, so that's out. C is no good. Next one, 1 banana and 3 apples, 0.5 times 1 plus 1 times 3, that's 0.5 plus 3, that does equal 3.5. So delta is the correct answer. Next one, 5 bananas, 2 apples. So 5 bananas, 2 apples. 5 times 0.5 is 2.5, plus 1 times 2 is 2, and you're over. That's like $4.50, so no. And the next one is 0.5 times 5 bananas, plus 1 times 1 banana, well that's 1, that's 2.5, and so yeah, 2.5 plus 1, that's 3.5. So your answers are Bravo, Delta, and Foxtrot. On to number 6. A group of 280 elementary school students and 40 adults, so if you look at 280 and 40, you have 320 people altogether, We're going on a field trip where they're planning to use 2 different types of buses to get to the destination. The first type of bus holds 50 people. The second type of bus holds 56 people. Andre says that 3 of the first type and 3 of the second will be all that the students need. Is he correct? Well, if I had 3 of the first type that holds 50, there you go right there. And then I add on to 3 of the other bus that holds 56. Well, there's 3 times 56. That, we'll see how many people that'll hold. Well, let's see. 3 times 50 is 150. 3 times 56 is 168. You add that up, there's 318, but we need a total of 320 seats. So it's slightly low. So no, it won't work. You're going to have 2 people without a seat. All right. On to number 7. Elena says equations A and B are not equivalent. So let's look at these two. Do a little bit of math. Let's do 13 minus 5x equals 48. Let's see if I can work with this one a little bit. This thing has like a 5x on one side and a numbers on the other. So it looks like we just want to kind of coalesce this thing. So let's see what happens. You got a couple ways. Again, with algebra, there's always more than one way to fix this stuff. I'm going to go and move the 5x over to here, and I'll put all the numbers over here. All right. How do I do that? Well, I have to subtract 40 from each side, and then I have to add 5x to each side. Okay. So when I add 5x over to here, it goes away, and it comes over on this side. So there's your plus 5x. And then when I subtract 40 from each side, it goes away over here, and it shows up over here. So 13 minus 40. All right. Well, 13 minus 40 is a negative 27, equaling 5x. And so, no, this little number right here is jacked up. So, nope. Number 8. To grow properly, each tomato plant needs 1.5 square feet of soil, and each broccoli needs 2 1/4 square feet of soil. The graph below shows the different combinations of broccoli and tomato in an 18 square foot plot of soil. Okay. So match each point to a statement it describes. So point A, which is right here, what do you got? You have no tomato plants, and you have 8 total broccoli plants. Right? So point A goes on here. Only broccoli was planted, but the plot is fully used and the plants can grow properly. Yeah, I'll buy that. Point B, where's that at? Uh-oh, it's not on the line. Point B. Let's see, you've got 3 tomato plants and 2 broccolis. That's what that's telling me. 3 tomato plants, 2 broccoli are planted. There is still extra space in the plot. Yeah, there's plenty of room left for more vegetables. Point C. Point C is on the line, and it corresponds to 6 tomato plants and 4 broccoli, and you should be fully utilized, it sounds like. So the soil is used, 6 tomatoes, 4 broccolis, yeah, and it's fully utilized. And point D, delta, right there, you're overstuffing stuff. Right, so you've got 4 tomato plants, you've got 6 broccolis, and you're above the line, so you're packing it in too tight. So with 4 tomato plants and 6 broccoli plants, the plot is overcrowded. Exactly. Okay. So 2, 3, 1, 4 on that one. Number 9. Select all the equations that are equivalent to this equation right here. So we're going through and see if we can do this. How do I get from here to here? Well, I can just look at this. 3x is all by itself, so if I move that 4 to the other side, I add 4. 5 plus 4 is 9, so yeah, that one looks pretty close to it. Okay. Let's look at this one and this one. It looks like they added 4 to each side, so that maintained the equality since you did the same thing to both sides. So yeah, that one looks good. X minus 4 equals 2. I don't know what they're doing here. It looks like they divided this thing by 3 and then they subtracted 3 from 5. They did nothing to the 4, so that's completely jacked up. they did so many things wrong in there, it's hard to kind of lose and count. There's so many things wrong with that. X equals 9. Okay, so we know that if we take this thing, so 3x minus 4 equals 5. And like that first one, we added 4 to both sides. And so I got 3x equals 9. And I can divide both sides by 3. Okay, and 9 divided by 3 is 3. So x equals 3. And you look at the next one, what do you see? X equals 9. Is that right? Does x equal 9? I'm thinking x equals 3. So somehow that one got circled, but I don't think that's right. We can actually check our work. All right. If it is true, we can put up here, what is 3 times 9? That's 27. 27 minus 4 is 23, which is definitely not 50. So I know that that one was circled in error. And then let's look at this last one. So I got a negative 3x, so it looks like they took the 3x over onto this side. I got a minus 4, which is the same as I got down here. And then I got the 5 on the right hand side. So yeah, that's an equivalent statement. They just simply moved the 3x over. That's all they did. But, right. And then the last problem here. Hansen solving the equation. He took the steps acceptable. Equations are not true. What can Han conclude as a result of these acceptable steps? So let's see. He went through. Did he do everything correctly? So what did he do? He applied the commutative theory. Okay, so he moved this one over here. And then he moved the 5 over. So that's still a negative 2. Is that still minus 2x? That's still a plus 5. Okay, we'll go. I'm okay with that. And then what did they do? Okay, it said 7x minus 2x is 5x. I'll buy that. That looks good. And the plus 5 comes down. And then we say, well, I got a 5x and a 5x. I'm not going to worry too much about that because x could be 0. X could be 0. You never know. All right, can I subtract this over to this side? Well, if I put 6 over to here, I must minus, that should be like a negative 1. But yeah, that's, and when you subtract 5x from each side, you get to be a 0. So this needs to be then it actually needs to be a negative 1. All right. So 0 equal negative 1. No solution. There's no value of our x that makes this equation true. Sorry, you end up with a disparity. So that's it. Nope. All right. And that's all your practice problems. Thank you for your time.